Hi everyone. So today we are going to discuss polymorphism. So before going to start the polymorphism, so yesterday class, uh, I revised the yesterday class. Then these are the contents in the fourth unit syllabus. Yesterday we discussed about pointers. What is a pointer? What are the features of pointers? Pointer declaration, how to declare the pointer. Then pointer to class, pointer to object, this pointer and pointer to derived classes and base classes. Yesterday we discussed. Okay. Then this is a pointer. A pointer is a variable, memory variable that holds the address of the another variable. Clear? Your pointer can have any name that is legal for other variables. Clear, all of you? It is declared the same way as other variables, but it is always denoted by asterisk operator. In pointer concepts, there are two operators playing major roles. In pointer concepts, there are two operators playing major roles. The first one is asterisk operator. This is indirection operator. This is also known as indirection operator. Then second one is ampersand operator. That is an address operator. Clear? So indirection operator, it shows the contents. Asterisk shows the contents in the particular memory location. Okay, this is the general syntax of the pointer declaration. Here type asterisk variable name, that is the general syntax. Next one is example integer asterisk x plus to asterisk f character asterisk c. Clear? Character asterisk c. Then these are the general examples. Clear, all of you? Here asterisk x, how to identify is it pointer variable or not? A variable name prefixed with asterisk, that is the pointer variable. Asterisk x. Okay, clear? Asterisk f, asterisk c. So these are the pointer variables. A type, the first variable type is integer, the second variable type is float, the third variable type is character. Clear? Then example come here. So where x is a pointer variable, x is a general ordinary variable and pointer is a pointer variable, where ptr p equal to ampersand x. So x address assigned into p. For example, here ptr equal to ampersand x, where x address, what is an address of x? Here 1001 assigned into ptr memory location. Here asterisk p, that shows the content into an address location. That's why here asterisk is an indirection operator. Simply it can collect the value from the 1001 address location. Which is the 1001 address location? So this is x. Okay, so then simply asterisk ptr received a value from the x memory location. That's why so x is so here asterisk x is asterisk is called indirection operator. Clear? So here simply what is the definition of pointer? A pointer is a variable which holds the address of the another variable. A pointer is a variable, memory variable. It holds the address of the another variable. It holds. Here ptr is a pointer variable. It holds the address of the x. Clear? It holds the address of the x. All of you. Then the next one, these are the features of pointers. Then here pointer to classes. How to define it? Then this is a class. Man, this is a man class. Then how to define a pointer variable. Pointer to class. Here man asterisk ptr. What is a ptr? Ptr is a pointer variable. This is an object of the man class. Then here pointer object. Here ptr, where m is an ordinary object, then ptr is a pointer object. Ampersand m equal to ptr. Then authorcase and party to assign into ptr memory location pointer variable. Then this is the clear screen. Then cout name, m2 name, then cout is. Okay, simply what is our concept now? Pointer to class. So the ptr and m, these two are the class objects. Clear? Class variables. Here simply man asterisk ptr. Here ptr is a pointer object, m is an ordinary object. where PTR pointer variable equal to class variable, that is m, ampersand m. M address assigned into PTR. Remember all of you. Then objects also having memory locations. Clear? Then the next one is pointed to object, same as the previous example. Here B is a ordinary variable. Bill asterisk B PTR. This is a pointer object. Then equal to ampersand B. Same as the previous example. BTR to BPTR to get data, then BPTR dot show. Okay, clear? Next one is this pointer. This pointer is used to show the current object. Okay, current object. Clear, all of you? Then the next one is, this is an example for this pointer. Next one, pointed to derived classes and base classes. Here then two classes, A class and B class. Then here A asterisk BP. This is a base class object, base. BP equal to ampersand base. Clear? Then the next one is here B class object B. Clear? Here BP equal to ampersand B. What is B? B is an object of the B class. Here BP is a pointer object of the base class. Clear? Where base class object equal to derived class object. Clear? Pointer to derived classes and base classes. Next one is the today's concept we are discussing. We are going to learn polymorphism. Okay, simply already I taught in third unit what is polymorphism. Polymorphism is a simply Greek word. It is a Greek word. Clear, all of you? Polymorphism is a Greek word. Okay, clear? So polymorphism is a Greek word. Poly means many, morphism means forms. Morph means forms. Clear, all of you? Polymorphism, poly means many, morphism means forms, many forms. Polymorphism means many forms. Polymorphism is a Greek word. Clear? So already I thought polymorphism. There are two types of polymorphisms: compile time polymorphism and runtime polymorphism. Polymorphism. This is the most important concept in fourth unit. Write and explain polymorphism in C++ with examples. So they may be asking 14 marks question. Clear? Here polymorphism is a Greek word. Here poly means many, morph means forms. Here polymorphism means many forms. Clear? Many forms. So after the inheritance, it is another most important feature of OOP. Clear? So it is the most important concept in OOPs. Clear, all of you? After the inheritance. So then in programming, polymorphism is the ability for objects of different classes related by inheritance to respond differently to the same function calls. Clear? So polymorphism is the ability for objects of different classes related by inheritance to respond differently to the same function call. In polymorphism, the member functions with same name are defined in base class and also in each derived class. Clear? And also in each derived class. Simply polymorphism. There are two types of polymorphisms here: compile time polymorphism and runtime polymorphism. Compile time polymorphism, what are the changes occurred in compilation time? That is called compile time polymorphism. What are the changes occurred in runtime? That is called runtime polymorphism. So what are the examples of compile time polymorphism? Here function overloading and operator overloading. We already discussed in second unit and third unit. Function overloading and operator overloading. Clear? Here polymorphism is a Greek word. Polymorphism is a Greek word. All of you. Polymorphism is a Greek word. So here poly means many, morph means forms, many forms. Clear? Many forms. Then here the two types of polymorphisms. The first one is compile time polymorphism. Second one is runtime polymorphism. Clear, all of you? Here compile time polymorphism is also known as early binding or static binding. Clear? Early binding or static binding. So then the next one is runtime polymorphism. Second one is runtime polymorphism. This is also known as late binding or dynamic binding. Runtime polymorphism is also known as late binding or dynamic binding. Here then what are the examples of compile time polymorphism? Here function overloading and operator overloading. So what is an example of runtime polymorphism? Virtual functions. This is the most important concept in the fourth unit. Already we discussed in the third unit virtual functions, virtual base classes, okay, abstract base classes. Already we discussed in the third unit. Then same concepts we will learn in the fourth unit. Clear? So examples for runtime polymorphism is virtual functions. Clear all of you? Then so binding. What is binding? Here simply binding refers to the process. Binding refers to the process. Okay, all of you. What is binding? Binding refers to the process that is used for converting functions and variables into machine language. All of you. So simply binding refers to the process that is used for converting functions and variables into machine language. The C++ supports two types of bindings. All of you. Then the C++ supports two types of bindings. Simply, a program in C++ is executed sequentially, line by line. We know. Yes or no? Either C language. So simply C language is a top to bottom approach. At the execution time, the compiler starts with main function, so it can execute line by line. Here same in C++ also. At the program execution time, the compiler executes one by one line by line. Clear? All of you. Line by line. After compilation, each line of source code is transformed into machine language. Clear? So why? So then each line of code that is in our high level language, the high level that is user language, the user language code convert into machine language. So this is an online bit. Remember all of you. So simply what is binding? So dash refers to the process that is used for converting functions and variables into machine language. So dash refers, that is the assessment question. Dash refers, binding refers to the process that is used for converting functions and variables into machine language. Then the next one, the process that is used for converting functions and variables into dash language. That is also assessment question. Here three assessment questions. The first one is dash refers to the process that is used for converting functions and variables into machine language. That is binding. So your functions and variables, you're converting functions and variables into dash language, that is machine language. Second question. Your C++ supports dash types of bindings. Third question, two types. C++ supports dash types of bindings, two types of bindings. Remember all of you. Okay, three questions from binding, assessment questions. Okay. So it is informed to machine language. Clear? When a function calls encountered by the compiler during execution, a function calls is encountered. So when it will execute at the program execution time, encountered means it can execute at the program execution time. Clear? So at the compiler execution, the function call is transformed into machine language. The function call is transformed into machine language. Dash language, machine language. Assessment question. Machine language, and a sequential address is provided. And a sequential address is provided at the compilation time. It can match the addresses, which is the calling function, which is the called function. It can arrange the links between calling and called functions. Clear? So then, for example, here then there is a train. Then the compartments, various places, compartments located at different places. Then those compartments, for example, 10 compartments collected. Okay. Then they are, before going to run the train, then they are arranged, they are fixed the links between compartments and engine. Clear? Then they will run. Otherwise, the engine only moving. Clear? The engine will only moves. Then the compartments will not move. Why? Then there is no links between compartment to compartment. Clear? So before going to move the train, they want to collect compartments and connect between links between, okay, compartment to compartment. Here also the same. Before executing the program at the compile time, so it can arrange the addresses from function to function. Okay, simply machine language and a sequential address is provided. Clear? Sequential address is provided. Thus, binding refers to the process that is used for converting functions and variables into machine language. Simply in C++ supports two types of bindings. They are static binding. Static binding is also known as early binding. Then second one is called dynamic binding or late binding. Clear all of you? Here compile time polymorphism and runtime polymorphism. Static binding, dynamic binding, early binding, late binding. Clear? Then this is the binding. Clear all of you? Then here static binding. What is static binding? What are the changes occurred in compile time? That is called static binding or early binding. So why it is called early binding? Before executing the program, what are the changes occur in the compile time? Before. So changes occur in early. That is called early binding or static binding. This informs is known to the compiler at the compile time, and therefore compiler is able to select the appropriate function for a particular call at the compile time itself. So it is called early binding or compile time binding or static linking. Clear all of you? So I repeat, this information is known to the compiler at the compile time. Therefore, compiler is able to select the appropriate function for a particular call, which is the calling function, which is the called function. What are the actual arguments sending through calling function? What are the formal arguments receiving from calling function? Simple, it can arrange the links between calling function and called function. Clear? So it can arrange the links between calling and called, actual and formal parameters. Appropriate function for a particular call at the compile time itself. So it is called early binding or compile time binding or static linking. Static linking. Clear all of you? So this type of polymorphism is implemented using overloaded functions and operators. Simple function overloading and operator overloading. Compile time polymorphism examples for compile time polymorphism is so function overloading and operator overloading. So here static binding. Okay, here compile time polymorphism is implemented using overloaded functions and operators. The overloaded member functions are selected for invoking by matching arguments, both types and numbers. Clear? Both types and numbers. Okay. Then the next one is dynamic binding. What is dynamic binding? Simply the appropriate version. What are the example programs for static binding? So till yesterday class, what are the programs executed? Okay, those are all example programs for compile time polymorphism. Clear? function overloading, operator overloading programs, inheritance programs. Those are all the compile time polymorphism examples. Then here static binding. Simply, what is static binding? Here static binding. This is also known as dynamic binding. This is also known as late binding. Okay, this is also known as late binding. So here dynamic binding using in virtual functions. Clear. The appropriate version of function will be invoked at runtime since the function is linked with a particular class much later after the compilation. Much later after the compilation. That's why this is called late binding. That's why this is called late binding. So compilation. This process is termed as late binding. This also known as dynamic binding. Since the selection of appropriate function is done dynamically at runtime, it is implemented with virtual functions. It is implemented with virtual functions. What is dynamic binding? After compilation, what are the changes occurred in program execution time? That is called dynamic binding or late binding. Clear? So then the next one is, this is an example program for dynamic binding. This is an example program for dynamic binding. This is the base class. Then this is the derived class. Then this is the base class member function. Then show virtual void. So simply virtual keyword is used in the dynamic binding. Okay, here virtual this is a virtual functions. This is an example for dynamic polymorphism. Clear? So then virtual show function, this is the base class member function and this is the derived class member function. So then here virtual show base class member function, virtual show is the derived class member function. Clear all of you? Then in this example, here then base class object asterisk bptr, this is a pointer variable, then the general variable bptr equal to ampersand a bptr dot show. So which function will executed first? So then in the base class member function will executed. Why? Then here virtual keyword is, here priority is base class member function bptr. Then here bptr is a base class pointer variable. That's why the virtual function, then there is no confusion. Simply here it will show the base class member function, show function. Then b is an object of the second class, that is called derived class object. Then bptr equal to ampersand b. bptr is a base class object. Then ampersand b is an address of derived class object assigned into base class pointer variable. Then bptr dot show, then it will execute the second derived class show function. Then b value equal to 2. Then this is an output. This is derived base class object value. Then this is the derived class object value. Clear all of you? Then okay, all of you. So then so explain about derived class and base class objects. Clear? Explain about base and derived class objects. Explain about base and derived class objects. In inheritance, the derived class inherits all the properties of the base class. Clear? So pointers to the base class objects are type compatible with the pointers to derived class objects. So a base class pointer can point to the object of the derived class, but a pointer to the derived class object cannot point to the object of the base class. Remember all of you, base class pointer can point to the object of the derived class, but reverse it will not support. Base class pointer object can point to the object of the derived class, but a pointer to the derived class object cannot point to the object of the base class. Come back. The given example, Here A is a base class name. Asterisk BPTR is a base class pointer object. Then where B is a base class object, derived class object, BPTR equal to ampersand B. So it is possible. Okay. But B is a derived class name. Then B is an object of the derived class. But asterisk B, where BPTR equal to ampersand B, it will not accept. And also asterisk B equal to ampersand BPTR, it will not accept. Simply in the pointer derived class object, okay, derived class pointer object will not allow the base class addresses, will not pointing to the base class object. Clear, all of you? Then so the base class pointer can point to the object of the derived class. Remember, all of you. But a pointer to the derived class object cannot point to the object of the base class. So in this diagram here, base class pointer, then base class object, derived class object, and derived class pointer, derived class pointers. Simply your base class pointer allows base class object and derived class objects. So then here derived class objects allows only derived class pointers, but it will not allows base class object and base class pointers. Clear? That is the next one. This is an example for the base and derived class objects. Clear? This is an example for base and derived class objects. Here simply hash include this is the base class, then this is the derived class, then A is a base class name, and BPTR is a base class pointer variable. Then BPTR equal to new A of 20. This is a constructor member function. At the calling time, it will pass the 20 value to the A constructor, base class A constructor member function. Now A is equal to X. Object BPTR is initialized. Now BPTR dot A equal to 20. Then delete BPTR. Come here and new and delete. These two are the memory allocation operators. Memory allocation operator is a new. Delete is a delete operator like malloc calloc function. Then free function, delete operator like free function. Then new operator like malloc and calloc functions in the C language. Here new is a keyword. It is used to assign the memory to a particular variable. So that's why this is called memory allocation operator in C++. Then delete is a keyword. It is used to free the memory, means release the memory. Then delete the memory of a particular object. Delete. Clear? Then here BPTR equal to new. BPTR is a base class pointer object equal to new B. What is B? B is a derived class name. So then 10, 20. So it can call the derived class constructor member function, that is B integer X integer Y. Then now X value equal to 10 and Y value equal to 20. Now B equal to A. Then the A constructor will execute it. Clear? Then here BPTR to show function, then return 0. Then this is an output. A is equal to 20. A is equal to 10, A is equal to 10 and B is equal to 20. Then observe all of you. Then here 2 times displayed. Then simply BPTR dot show. It can call the show function. Clear all of you? This is the show function. So here, so in derived class object. So first one execute the base class member function 2 times. Why? Here integer A, then colon A. This is the constructor member function. It can execute again. Clear? Then execute the B function 2 times. That's why he displayed A value and B value. Clear all of you? Then this is called constructor member function. Before going to execute the derived class constructor, and it can execute the base class constructor. The previous value equal to 10, the present value equal to 20. Clear? Now x value equal to 20, y value equal to, sorry. Now x value equal to 10 and y value equal to 20. It will pass the x value to the here base constructor. Clear? Then simply what is our concept? So now we are discussing base and derived class objects. Then here BPTR is a base class object. Then the next one B is a derived class object, but it is only executing derived class constructor member function. It will not create any object. But at the function calling time, means here BPTR equal to new B of 10, 20. This is the class name B. Then it will pass these two arguments to the B class, that is derived class member function. Now x equal to 10 and y equal to 20, b equal to y. Clear? Then this is an output for this example. Then the next one is virtual function, most important, all of you. So this is most important. So you will get question from virtual functions in the 4th unit. Then there are 3 questions. First one is write and explain pointer. Second one is write and explain binding or polymorphism. Third one is virtual functions. Clear? Third one is virtual functions. All of you. So what is virtual function? Already we discussed virtual function. Then how to form a question? What is virtual function? What are its rules? Explain with an example. Already we discussed in the 3rd unit. Okay, virtual functions. Then virtual base class. Then the next one, abstract classes. Already we discussed the same concept repeated here. Clear? So here virtual functions. How to form a question? What is virtual function? What are its rules? Explain with an example. What is virtual function? What are its rules? Explain with an example. Or explain about runtime polymorphism with an example. So here virtual runtime polymorphism examples for virtual functions. Clear? Don't forget either runtime polymorphism or virtual functions. Both are same meaning. Write and explain virtual functions or write and explain runtime polymorphism. Clear? How many ways to form a question of the same concept? What is a virtual function? What are its rules? Explain with an example. Or explain about runtime polymorphism with an example. Clear? In the inheritance, the same function name in both base and derived classes. The function in base class is declared as virtual using virtual keyword precedes its normal declaration. When a function is made virtual, the C++ determines which function is to be used at runtime based on the type of object pointed by the base pointer rather than the type of the pointer. Already we discussed. So the previous example in the so we are using show function in both classes, same function, wide show. Then there is a base class member function prefixed with a virtual keyword. Observe all of you. Already we discussed. Here clearly virtual wide show, here base class member function, here cout, then etc. Clear? All of you. Then virtual functions. Simply what is virtual function? In inheritance, the same function name in both base and derived classes. Show already seen. So the function in base class is declared as virtual using virtual keyword. Clear? So here simply the virtual keyword, I repeat the same. In inheritance, the same function name in both base and derived classes, it is show in base class and show in derived class. Clear? both base and derived classes. The function in base class is declared as virtual using virtual keyword. This is virtual keyword in the base class member function. So declared as virtual keyword preceded its normal declaration. Clear? This is the normal declaration. This is preceded virtual keyword. Clear all of you? So then when a function is made virtual in C++ determines which function is to be used at runtime. Which function is to be used at runtime based on the type of object pointed by the base class pointer rather than the type of a pointer. Clear all of you? This is virtual function. So these are the rules already we discussed in the third unit. Again I repeat, the virtual functions must be members of some class. They can't be static members. Clear? They can't be static members. Why? Where we are now? Virtual, that means that is dynamic binding. Dynamic means that is runtime. Clear? So they can't be they are accessed by using object pointers. Clear? All of you? Then a virtual function can be friend of another class. Constructors can't be virtual. Destructors can be declared as virtual. The prototypes of base class and derived class must be same. Void, void, or int, int, float, float, character, character. The base class member function prototype int, integer void show, integer show or void show. Then the derived class member function also same. We should maintain same. Void show or integer show or float show, etc. The prototype of base class and derived class must be same. Otherwise, the virtual mechanism is ignored. Clear? The operator overloading is also supports the virtual mechanism if a base class contains virtual function and if the same function is not redefined in derived classes. In such a case, the base class function is invoked. Clear all of you? These are the rules for virtual functions. Okay, these are the rules for virtual functions. Okay, all of you. So then, so tomorrow class we will discuss in detail virtual functions. Okay, so the two topics completed. The first one is pointers and the second one is binding polymorphisms. And tomorrow class we will complete the virtual functions. We will learn virtual functions. Clear? So virtual functions already we discussed, but tomorrow we will discuss in detail. Clear all of you? Bye.